Welcome to factoring a sum or difference of cubes. This is one of the forms of factoring where you pretty much have to memorize these formulas. It's not intuitive like a lot of the other factoring techniques. A couple things to notice is that it can be a sum or a difference of cubes and it will factor. Remember, when you have squares, it has to be a difference. Also notice that a sum and difference of cubes does factor into a binomial times a trinomial. I would like to take a moment though and verify at least one of these formulas. If the sum of cubes has these two factors, that means these two factors should divide evenly into a cubed plus b cubed. So what we'll do before we start is take this sum of cubes and divide by a plus b to make sure that we will obtain a squared minus ab plus b squared as the quotient. So it's going to look something like this. Now, the first thing we're going to do is put in some zero terms so everything lines up nicely. This is what I mean by that. We're going to put in plus 0 a squared b plus 0 ab squared, and then we have plus b cubed. Okay, we'll go ahead and start now. What times a will give us a cubed? Well, that would be a squared. Now we multiply a squared times the quantity a plus b. That would give us a cubed plus a squared b. Now remember, when you're performing long division, you actually subtract each time. But instead of subtracting these, what we're going to do is add the opposites. So we'll change this to addition. That will become negative, and that will become negative. So the result here is negative a squared b. Then we bring down the next term, plus 0 ab squared. And now we repeat. What times a will give us negative a squared b? That would be a negative ab, so we'll write down minus ab. Now we'll multiply a negative ab times a, that would be negative a squared b, and then we have a negative ab squared. Instead of subtracting, now we'll add the opposites. So the result here is a positive ab squared. Bring down our last term. Go through this one more time. What times a will give us ab squared? That would be b squared. So now we'll multiply. B squared times a, that's ab squared, and b squared times b would give us b to the third. Now, since these are the same, if we subtract, we have a remainder of 0, which is what we expect. So since the quotient is a squared minus ab plus b squared, we have verified that a cubed plus b cubed must equal the divisor, a plus b, times our quotient, a squared minus ab plus b squared. Now I would encourage you to go ahead and try this with the difference of cubes as well, just to verify those formulas are valid. Let's go ahead and try some factoring problems now. If we want to factor a cubed minus 27, the first step is to verify that we do have a difference of cubes. Well, it's pretty obvious x cubed is a perfect cube. We can write this as x raised to the third power. 27 does have three equal factors. 27 is equal to 3 to the third power. So what I like to do is actually list the value of a and b before I use the formula. So looking at the second formula here, we can see that a is equal to x and our b is equal to 3. Let's go ahead and fill out the formula now. X cubed minus 27 must equal a binomial times a trinomial. The binomial is going to be a minus b, that would be x minus 3. The trinomial starts with a squared, that would be x squared, plus a times b. Well, a times b would be x times 3, or 3x. And then lastly we have plus b squared. B squared would be 3 squared, or 9. Let's go ahead and try another one. Again, the first step is to verify that we do have a sum or difference of cubes. But the problem here is that 5x cubed does not have three equal factors. But we're actually asking the wrong question. Remember, the first step in any factoring problem is to look for the greatest common factor. And these two terms do have a common factor of 5. It's extremely important that we never forget about the first step in factoring, which is look for the greatest common factor. Let's go ahead and factor the 5 out. That would give us x cubed. If we factor a 5 out of 575, we're left with 125. Now we do have a sum of cubes, because I can write this as x to the third power plus 5 to the third power is equal to 125. So now we'll use the first formula where a is equal to x and b is equal to 5. We need to be a little careful here. Let's go ahead and rewrite this. This is going to equal 5 times a binomial times a trinomial. So our binomial will be a plus b, x plus 5. Our trinomial is going to be a squared, which is x squared, minus a times b, minus x times 5 will be minus 5x, plus b squared would be 5 squared, which equals 25. Okay, I hope you found this video helpful. Thank you and have a good day.